Greetings. Today I'd like to show you this little program I've been working on in Haskell. It handles polynomials and it is able to perform a Lagrangian interpolation, polynomial interpolation, which means that this program can be used to securely share secrets. If you want to make sure that you got to put at least 5 keys or at least 6 keys or n keys together in order to actually get the secrets. Um, so, the actual secret sharing is down here at the bottom. So this one just takes n random points off of the polynomial f. Uses a c to actually take the random points, and then this one right here is the one that actually interpolates it back into the original polynomial. So let's see how this works. I'm just gonna open a terminal here, and I'm gonna open up my program. And let's say I'm an executive or I'm a CEO. I'm a CEO of a big company and I have a safe in my office and I have some very important things in there. And I want to be sure that if something happens to me, then my executives can get to that whatever is in that safe. So let's say my combination for the safe is 1, 2, 3, 4. That's just a series of numbers. Very secure. So let's say I want to share that number with my executives, but I want to share it in a way that they cannot, one executive or two executives cannot open the safe on their own. They actually need to agree at least, let's say at least 5 executives need to agree to open the safe, and then they got to put their keys together, and then they can actually reveal the locker combination or the safe combination and open it. So how do we do this? Well, let's say I have 5 executives. 5 executives. So what I'm going to do is actually put my combination in a polynomial. Polynomials, if you don't know, they're basically, for our purposes, series of numbers. Really there are series of elements in a ring, but for our purposes, they're just series of numbers. They're more than that, but so into our first list element here, I'm going to put my actual combination. So 1, 2, 3, 4. And I have 5 executives that I want to share these keys with, or at least there's 5 executives. They got to put their keys together in order to actually get this combination back. So what I got to do is I got to add 4 more coefficients so I can have 5 coefficients in total. So let's say I had 23, 16, 4, and 78. So that's 5. How do I actually share this in a way that one person cannot access it, but if 5 people put their keys together, then they're going to be able to access this? So what I'm going to do is I'm going to say poly share secret, and then I have my polynomial. And actually, before I do that, I got to generate a seed. So let's do that quickly. And now I'm going to say poly share secret, and then I have my polynomial. I'm gonna generate 5 keys. I need to generate at least 5 keys. I could generate more. I could generate 6. So let's generate 6 for the sake of demonstration. Just so you can see that you actually only need 5 of these keys. And finally, we're gonna put in our seed that we just generated. Once that's done, it returns this horrible, scary little mess. But actually what this is this is a list of keys. So it generated 6 keys for our polynomial. So what I'm actually going to do is I'm going to copy these keys out. So I'm going to put my text editor up here, and I'm going to go ahead and copy all of these keys out. Just gotta make sure I can get parentheses to parentheses with those. Don't need a comma there. This is our first key. This is our second key. this is our third key. This is our fourth key. And this is our fifth key. And we have one more that I can't see the bottom of. Okay, there it is. And this is key number 6. So let's say I have 6 executives in total. At least 5 of them have to agree to open the safe to actually get the combination. So this is going to be key number 1. This is our key number 2. Key number 3. Key number 4. Key number 5. And key number 6. So again, because our polynomial had 5 coefficient, we need at least 5 of these keys. But I generated 6 keys, so I can use 5 from any of these 6. So what I'm going to do now here in my terminal is I'm just going to quit. In fact, I'm just going to go ahead and close the terminal altogether. So I just have my keys here. The terminal is gone. Everything that was in the memory there was completely deleted. And I only have my keys now. So we're just going to use these keys now to get my polynomial back. So I'm going to open a brand new terminal. Just got to put it down here. I'm going to go into my program again. And this time what I'm going to do, just for the sake of comfort, I'm going to put the series of keys back in here into a variable. And actually, I'm going to say this, otherwise it's going to give me an error. So I can take 6 or 5 of these keys. Any 5 will do. So let's say I'm not going to take the first key. I'm going to take the other 5. So I'm going to take this key. So this executive number 2, he gives his key or her key. Executive number 3 gives their key. Executive number 4 gives their key. And executive number 5 gives their key, and they are 1 shy. And finally, executive number 6 gives their key as well. So we only have 5 of the 6 keys. So we did not actually use this key, but we could have. We have our key list stored in a variable x, and now if I say restore or poly restore secret s, I'm gonna get back my polynomial that I generated. So this wasn't stored anywhere. We just used the keys to generate this polynomial back. Now, just to show you, we need at least 5 keys to generate this polynomial back. But if we're just 1 shy, we're already nowhere closer to actually. So if you have just 1 key less, if you have only 4 keys, then you will have no idea. Just getting another key will not get you any closer to knowing what the combination is or what the secret is. Only if you actually have all the keys, then you can get the whole thing. So I'm going to just go ahead and delete the last key we entered here. We cannot do that here. So I'm just going to go ahead and do this. So it's actually 1 key less in there. So we're 1 shy. We only have 4 keys, not enough to actually get back my original polynomial. So I'm going to try and restore my secret this way. And all I'm getting back is garbage. So, as you can see, if you can actually deduce from this that the original combination is 1, 2, 3, 4, well, I mean, you're just an incredible genius. So this does not get you any closer if you only have 4 keys. This is just not gonna get you anywhere. So let's take our little key set here, and we're going to actually put in our first key. So now key 6 is not in there, but we're going to put in key 1 instead. And we're going to just put that in. And now we're going to restore the secret, and it still works. So as long as I have 5, any of these keys, if I have 5 different keys in there, I can have more, but at least 5 different keys in there, then I can restore the secret. So that is how this works. I hope you enjoyed this little demonstration. Hopefully I'll be able to develop this a little bit further, add a little bit of extra security with the modulo thing, and maybe do things like actually write these keys out to a file and read them or something. But I'm not quite there with Haskell yet, so my actual Haskell skills are really poor. This is just a mathematical theorem thing that, you know, already existed, and I just sort of implemented it. So thanks for watching, and I'll see you soon.